Data structures. Anyone? Data structure. Can anyone tell me what is that? What is data structures?
Efficient way of storing data.
Okay, great. Thank you, Kaushik. And can anyone tell me what are the types of data structures?
Linear and hierarchical.
That's great. Okay. So can you tell me what are the subtypes are there in linear?
Skew, linked list.
Yeah. So
When stack.
yes. So the linked list can be set to as linked list and stack and then queue. So can you differentiate what is list, what is stack, and what is queue? So anyone starts from number one. So can anyone say what is list and another person say what is stack and what other person say what is queue? So starts with list. Can anyone?
Linked list consists of nodes. Each node consists of data and an address to the next node.
Okay. So
And starts with head, ends with null.
great. So it has the address and points to the next node. Okay. And so can you define apart from Ishita? So can anyone define the structure of the node? Sorry, structure of the list. Abhinav, Abhijit, can anyone? So
The linked list has multiple nodes. Each node has its own data and pointer to the next node.
yeah, I'm asking how we can struct the node so that we can build the node. So in use of code, using the code, how you can build.
Linked list has a structure inside of a node,
Mm-hmm.
which consists of data and a pointer to the next element in the linked list. And there are two nodes which are defined inside the linked list. One would be your head node and one would be your tail node. Head is the first pointer to the first element in the node, and tail is a pointer to the last element of the node.
Okay, so while we are initializing into the code structure, so we need to initialize the node. That is, we can put a keyword as node next, and so we need to create a constructor. So inside constructor, we reference to the variable, so that is the null value. So and after behind that, we have to create two functions, that is for insert and delete, and then only inside the main function only we can add the elements into the list. So this is what the implementation of list. So this is first we need to structure the node and create a method, that is two methods for insert and deleter, and inside main method we are adding that elements into the list, and we can call the methods to display the list, or else we can delete the list using the call method itself. So this is what list. Can anyone define what is stack? Sai Pranit. Sai Pranit, are you there? Rishad. Or does anyone define what is stack?
Stack is an abstract data structure which follows last in, first out, and
So
it can be implemented by the array list on the queue.
yes, that's a good definition. Okay, so same as like stack, so we can implement a list also. Sorry, we can implement a queue also using the linked list and the array. So same as like, but whereas the queue follows FIFO principle. So that is first in first out. where stack follows LIFO. So this is the main definition, and push and pop for insert and deleting into the stack, and Q and D, NQ and DQ for deleting the elements from the stack. So yesterday you've gone through the program, because yesterday so many of them felt so tired. So what about the program that I have sent in the chat box? Have you go through? So today, is it a holiday or else is it a working day?
It was a holiday, ma'am, but many teachers made extra classes for CAT 2 syllabus.
Oh, okay. So you didn't have a free time today itself. Am I right?
Yes, no free time, and we had some company test also. It also didn't happen, so it wasted a lot of time.
Okay. So you didn't go through any programs today. So like like Kaushik said, so all of them didn't go through any program. So what I have sent yesterday,
Only stack, ma'am.
only stack. So you got any doubts, Ishita, inside the stack?
Yes, ma'am.
What?
Ma'am, in the third program, I'm not able to understand one small point.
Yes.
Uh,
Third, inside the stack yesterday. Okay, fine.
yes, ma'am. The question basically was you have to check whether the numbers are consecutive or not.
Yes.
And in that, actually, I'm understanding the logic and everything. But while like in the stack, whatever you have given as the stack elements, there are two pairs that are not consecutive. But when we return, we can only see one of the pairs. Like the return, when we return, it will say yes, it will say false. They are not. They don't. All the elements are not
Yesterday
consecutive.
itself, I just run the program. I ran the program itself without the consecutive elements. It said no. Yesterday I ran this. Right. Wait, I will check the program is. So inside stack, right?
Yes, ma'am. The last question.
Yes. Yes. Oh, wait, I will share you the screen. And one more thing I need to say. So I gathered the question from my management, so that so the in-depth concept of the functionalities. So where we are using the functionalities, we need likewise someone said we need an in-depth concept. So why we are using this? So likewise, so if you're having doubts regarding this, you can directly ask here itself. I will convey you. So here, apart from here, I will explain the things where we need to. So the more explanations in the connectivities, where we have setting this logic. So logic in the sense, if auxiliary we need to put here, so this is the logic. So inside the logic you need a more explanation. In the sense, you can terribly ask here, so I will inform you why we are using this and all. Okay. And so can you able to see my screen, Ishita?
Yes, ma'am.
Yeah. So also I have run with this consecutive elements, and this is doesn't have the consecutive elements over here. So I will run this. I think it has consecutive elements. Yes, there is no consecutive elements, right? So the values is mischanged, like 6, 22, and the middle of that only the consecutive elements is there. So that is -6, -5, and 10 and 11. So these four are the consecutive elements, whereas these are not in the arrangement, the consecutive elements. So it sets no. So where
Yes,
I'm
ma'am.
adding,
The doubt I had is, do we not have to print that which of them are not consecutive, like 622, 21, 721? Do we?
likewise we need to write a condition. So that is the if where not the elements, so from the there is the all the values will be there in a stack. So it can't separate the value which is not consecutive, because if inside the stack we can add more elements here itself. I can add more elements. I can push the elements into the stack, so up to the maximum element reaches. So that's why it can't reaches. It can't split the elements where it is not consecutive and all. So if I am putting the consecutive elements in a line by line, so rather it tells the condition is it consecutive or not.
Yes, ma'am. Okay, ma'am. That was my only doubt, that
Yeah,
the output is not showing those
yeah,
elements.
because this is that. So if you are using normal program, it will separately do that thing. But it is a stack and push, so we are inserting the elements one by one, so it doesn't separate.
Yes, ma'am. But we can like implement it with an array and then show
Yeah,
individually.
yeah. If you are implementing apart from the array, you can put. But we are using the auxiliary stack here. So yesterday itself I told why we are using the auxiliary keyword. So for recursive function, we are using this auxiliary stack. So for if you are using the auxiliary, in the sense you can't implement in an array. So we can try it. You just try it tomorrow, and you can gather it to me. So you just try it with some arrays. I am also going to try. Okay. So this is a
Okay.
nice doubt. Okay, I will try it and I will let you know.
Yes, ma'am.
So
Thank you.
up to any others having any doubts? Only she only go through. What about others? What about others?
No doubt.
I think so. You didn't go through it. I think so. Okay. Because you guys having continuous classes and all. And Kaushik, you didn't. You also didn't go through anything.
I went through the first code a little bit from stack.
Okay. So are you clear with that?
Yes, ma'am.
Okay. So just go
I
through.
only
So
went through one code. Yes, I will go through the rest one.
okay. Just go through the rest of the codes also. And today also we are going to see the non-linear data structure. So that is what the easiest topic. So what is that? Can anyone see the example for non-linear data structure?
Tree, graph.
Yes, tree.
Free, ma'am.
Yeah, tree. Tree is the topic we are going to see today. So the tree. So inside tree we are going to see the binary tree. Can anyone tell me what is binary tree? Why the name says binary tree?
Each node points to two more nodes.
Yes, is that each node contains maximum, that is two children, exactly two children. So that is why it's said to be. So that is maximum of 0 to 2 children. That is it's said to be binary tree. So by in the sense 2. So the binary tree is nothing but a hierarchical data structure, hierarchical in the sense, so it tops to bottom. So we can calculate it from top to bottom. So that is hierarchical. So which node at most two children. So it needs at most two children. That is what it is named as binary tree. And where we are calculating the tree. So not only the binary tree, so every tree structure having the root node. So the root node is must, that is called to be an parent. So and every tree has the left node and the right node. So that is left subtree and right subtree. If the left node and right node having the children's in the sense, that is to be called as left subtree and right subtree. So here you can see the A is my root node. So here B having the children, that is from the B it is called as left subtree, and from C it is called as right subtree. So in this is also the left subtree of B, and this is not a tree actually. So E is the last leaf element. So E is not a tree. So this is the node alone, and whereas F is the right subtree of C. Okay, so this is what the subtree, and every node have its root node, left node, and right node, and the children node. So or children in the sense, so what is the least element, last element? So G, H, I, F, E or children's. So without having any children's in the sense, that is then this node is said to be children node. So this is also said to be external node, and this is also said to be internal node. So internal node in the sense, the parent node also called internal node. So the leaf node also called external node. So these are the terminologies we need to see. So this is not here. So these are the terminologies. So the tree must consist of root node. So the root node having the left node and the right node, and each this left node and right node we can calculate as left subtree and right subtree, and the internal node is it is said to be the parent node, and external node it is said to be the child node. So that's it. So you can understand the terminology over here. So this is the normal terminology. I'm just go through it. Are you clear? It is not in a PPT, so I'll just go through. Clear?
Yes.
Yeah, okay. So this has so binarity can be traversed in two ways, that is depth first search and birth first search. So we are going to see what is depth first and what is birth first. So can anyone know what is depth and what is birth? So if you have studied in mathematics now, you can tell me what is depth first search, DFS and BFS.
Depth will be like it goes through all the nodes before reaching the bottom node.
Yeah, in birth in the sense.
Breadth is like it looks at all the top level nodes first, I think.
Okay, we will see. So that is both first in the sense, the DEF first in the sense, depth first in the sense that has to be differentiated and divided into three parts, that is in order, pre-order and post-order. So likewise it sees the nodes from the level by level, so that is from root left or right, or left right or root, or else left root or right. So this has, so while this conditions are said to be DFS traversal. So birth first in the sense, so from starting node, so that is to be sees the level by level. So from starting A, B, C, so that is to be seen level by level. So now level by level in the sense A, B, D, C, G, and C, E, H, F, and I. This is what birth first. And depth first, it is divided into three types, that is in order, pre-order, and post-order. So we will see what is in order, what is pre-order, and what is post-order traversal. And before the traversal is nothing but it is the way to see the nodes, that is what traveling from one substation to another. So in easy way we can set it as traveling from one substation to another. So like if you are going to somewhere, so from the start source to destination, we are going to replace in stop in several substations. So that is what the traversal. So that is starting from source and to the destination. Up I'm traveling from Chennai to Mumbai. So from Chennai I need to go to the airport, and there I need to reach. So after reaching the airport, from there I need to go to the railway station. So this is what the traversal does. So we need to see the route one by one. So where are the various ways of seeing the trees by using this traversals. Okay, we will see. So what is the traversals, why we are going? So before that, in which way I can create is how the tree is to be created. So this it is a non-sequential order. So that is whereas list, stack and queue are in a sequential order. So that is the arrangement will be in a next by next. That is it is an arrangement of FIFO or else LIFO, or else it will be the next order. Whereas how the root, so the elements should be added in a tree. So this is what if I'm adding this element, how it is to be added. So can anyone explain this? How it is to be displayed as a tree here? 1, 2, 3, 4, 5, 6, 7 is my element. So whereas I declared first element as root. So 1 is there. How we can add 2, 3, 4, 5, 6 and 7 as a tree here? Can anyone know it? How we can arrange a tree? Either if it is a list, I can directly add into the list, or either if it is stack, I can 1, 2, 3, 4, 5 directly add into the stack. If it is a queue, I can add it from the rear end and delete it from the front end. So instead of taking the tree, so how we can add in the sense, so first element will be the root. So that is without root node, the tree doesn't to be formed. So first element, that is 1 is my root, whereas I'm going to take the next element, that is 2. So in case if you are inserting into the left subtree, the value must be lesser than the root node. Okay, that you can check it as the left subtree must have the lesser values and the right subtree must have the highest values. So that is the condition we need to use to create a binary tree or else any tree. So that is what it checks the value. So 2 is where I am going to put 2 or 3. So 2 is the least most value we are comparing to the others. So that is why I am representing into the left subtree. Whereas 3 is the highest value of comparing to 2 and 1. So that is what I am representing 3 here. Whereas I am comparing 4. So 4 is the highest value comparing 4 is the highest value comparing to 2. So this is what I'm just here it is, I'm replacing it to left node of 2. So that is left child of 2. So 5 is the highest value. So that is I'm replacing here itself, that is right child of 2. And after I'm going to 3, 6 and 7. 6 is the highest element. 6 and 7 will be the at last highest element in the node. So that is why I'm replacing it in a right node. So that is left node of right subtree and left node of 3 and right node of 3. So this is what right subtree and this is what left subtree. 2, 4, 5 are subtrees. So this is said to be left subtree and this is said to be right subtree. So here wise you can have, so every node holds the address fixed to the left and right node. So that is what is the address. So here doesn't address, there is no address there. Here you can separate. So there are 3 columns. So that is 1, 2, 3. So here is the value. So that is the element. So the center is the value. That is the element you are going to add. So and left and right is to be the address. So that is for address for left subtree and right subtree. So if you are going to add the elements in the left subtree and right subtree, it will be places to the addresses. So it will be remarkable from the addresses. So this is what a structure. So this is what the structure of the tree. But we can simply take it in, as like this. But the real structure of tree, here it is. So this right and left, there was the address of the tree. So that is I'm going to add one node into the left subtree. So that is left node of 1. So that is I'm representing the value. So that I'm sequencing the value 1, 2, 3, 4, 5, 6, 7, 8. That's it. So I'm just representing 1. So that is the left element is 2. And I'm going to add the next element as a right of the right subtree of 1. So that is I'm taking as the address 2. And my value is 3 here. So next I'm taking the address 3, and so I'm adding the element, next element 4 here. I'm next adding this right 3, so that is 5. So same, this tree only looks like this. So I'm going to add this 5 as the element as a right subtree. So I'm going to add this element, so that is to be called as 4. Sequential numbers 5, 6. So if there is no elements for this child nodes, you can represent as 0. This address to be represented as 0 because there is no elements for this child node. So that is why it is to be represented as 0. Whereas others having their child, you can represent the address in a sequential order, that is 1, 2, 3, 4 and n to n. So this is what the address. So understand how to create a tree and how we can represent the address. So this is what the structure of the tree. Up to this clear? Any doubts regarding the structure? Any doubts regarding the structure of the tree?
Looks similar to a double linked list.
Sorry, I can't understand.
It looks similar to a doubly linked
Yeah,
list.
it is similar to the, but not a list. It is not a list. It's just an address. Or you can't confuse the list over here because this non-linear hierarchical structure doesn't follows any hierarchy structure. So don't confuse that. But it is similar like a linked list. So that is what it points to the address to the nodes, but it is points to the list next nodes. But inside the list, it points to the next values up to the value reaches the null. Same like list exactly. But you don't confuse over there with this hierarchical structure. This is different, but this is too different. So if you clear now, you can. So if you are able to forget it, so you're not able to forget it now, you can remember a slack. So both the trees and linked list will be the same, but it follows the hierarchical structure. So hierarchical in the sense it starts from root and to left and right, but the linked list follows the list structure, that is from then next to next node. So can we move on to the next? Can we move on? Yeah, so you are going to tell me the answer. So this is my input. Okay, so 6, 2, 8, 7, 1, 4, 5, 3 and 9 is my input. So I'm going to create a tree here. So 6 is my root node. Okay. Okay, 6 is my root node. So I'm going to add this element. So where the 2 will be located? So it is the right or left? So the output is here. It is. So you can understand the tree clearly. 6 is my root node. So 2 is smaller than 6. So that is why I'm representing here. so that is left node, and 8 is I'm comparing to the root node, so that is 8 is greater than 6, that is why I'm representing here as a right node. So then I'm taking 7, so 7 is greater than 2 but lesser than 8, so that is why I'm representing as a left node of 8, and I'm taking 1, so I'm checking the 1 value, so this is 2 less than the 2, so 2 less than the 2, so that is why I'm representing the left child node of 2, and 4, so 4 I'm taking as representing this, 4 is the another smallest value, so that is, but it is greater than 2, so that is I'm representing the right node, so that is right node of 2, so I'm taking the value 5, so 5 is smallest than 8 as well as it is greatest than 4, so for this 4 node I am representing the 5 as a right child, and I'm taking this 3 value, so I'm checking this 3 value, it is too small than 8, so that is why too smaller than 8 and 7, so I'm checking it 4, so for 4 it is too small, so that is the only one value to be the difference, so that is why I'm representing this as a left child, and I'm last taking as 9, so 9 is greater than all the nodes, and that is why I'm representing the 9 is the right child of 8. So this is how we can create a tree using this element. So clear understand how we can add the elements as a hierarchical structure with the given element, so given input. So I'm going to give you the input, another input, so you have to tell. Wait, I'm giving the elements, that is 12, 16, mm, 14, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, can anyone, so my root node is 16. So where I need to represent, wait, okay, so my 16 is my root node. So can anyone tell me how, where the 12, 13, 99, 87, where will it be presented? So can anyone tell me I will form the root here?
12 will go at the place of 2.
Okay,
12 will be on the left, 13 on the right, yeah? For the first.
yeah, 12 here and the 13 here. Okay, it looks like this. So this is for the 16. And what about 19?
Right node of 13.
So wait a minute. Yeah, right node of 13. So exactly. So here right node of 13. And where 9 will be present?
Right node of 12.
The left node of 12.
Yes,
Sorry,
left node of
left node
12.
of 12.
Yeah, left node of 12. And where 8?
The left node of 9.
Yes, so here it to be. So here it to be changed. So I can't able to change. Okay, and where 7 will be presented? In the left node of again 8. Okay, so this is for the formation of tree. So if you can understand, so so wherever who didn't understand the concept while adding the trees, you can asked me. So some of them answered. So that's why I'm moving on to the next slide. So if you not understand how to arrange these elements, you can ask me. So anyone who didn't find
Small
the
doubt,
answer?
ma'am.
Yeah.
So we have 9, and then to the left of 9 we add 8,
Yes.
and then we add 7 to the left of 8.
Yes.
Okay. Then
Yeah.
8 then 9 has only one a child node, right?
Yeah, only one child. No, 9 will be having two child. So 9 will having the child left child node of 8, and 8 will having the left child node of 7.
Okay.
Yeah.
All right.
So it looks like this.
Ma'am, can you explain once again?
Yeah, sure. Sure.
And can you do it in MS Paint, ma'am? It will be more clear.
Okay. Wait, I will do it. Mm. So this is my input. Okay. So I have told. So I'm just taking the paint. So whereas the left child node, left nodes will be uh, the lesser nodes, and the right will be the highest node. So this is what the logic. So just find the logic where we need to import. So left must having that lesser nodes, and right must having the right node, right largest node, that's the highest node. So you need to compare with that one. It's loading. Sixteen, 12, 16, 12, 13. So where else I am going to insert the element? So that is 16 here. So this is my root node. Okay. So and after, so what is 12 and 13 is there in my tree. So node. So 12 and 13. So I need to compare this 12 and 13 over here. So 12 is smallest element, then 16. Right. While comparing 12 and 13, so 12 is the least smallest element. So that is I am putting 12 as a left child node, and so 13 as a right child. Okay, what is the next element?
Ma'am,
13, 19,
ma'am,
19,
ma'am, I
19.
have a doubt.
Yes,
Ma'am, after 16, you have kept 12 is in the left node.
yes,
Ma'am, how do we
yes,
get to know
yes,
that
yes,
12, we can have less than 12 number now, ma'am?
yes, yes. See. So this is not an answer. Yeah, see. So,
Suppose
so
we have a number called 8 after 12, then how it will take it?
8 after 12. So maybe
Yes.
the sequence. So 8 will be after 12 in the sense. So you need to represent 8 as a left child node of. So 8 must be the left child because it's the least most value comparing to 16 and 12. So you need to put it here.
So there will be only one left node.
Yeah, only left node. So because we need to arrange the order sequentially, so we can't mischange the elements, right? So if the some of them giving my the input, so ordering like some of them giving you the register number, so I need to take up the register number in order. I can't misshape it. So I need to likewise only I can arrange it. So 16, 12, and again the 8 will be the left node of 12.
Then what will be the right node, ma'am, here?
So right node is not here. So I need a hierarchical structure. So this is also to be the tree. So
Okay,
this is
ma'am.
also the tree. So this is also the tree, whereas this is also the tree. So without the left side of 16 also, so this is the root node, whereas root node having the left side left subtree alone, so without the right subtree. So this is I need a hierarchical structure, so without having any uh, subtrees.
Okay, ma'am.
Okay, that's it. So also, so we can see we need had a mistake. So this 13 I'm going to insert here. So 13 I'm going to insert here. So that is 13 is the most least element comparing to 16, right? Okay, but it is highest than 12. So I can replace 12. So 13 is the right node of 12. So likewise I can represent. Okay. Have you understand this logic what I have told now? Have you understood this logic? Why I have inserted 13 here? Any doubts now? You can ask me. Then 19, 9, 8 and 7. So whereas I need to insert 19 as a, because 19 is the largest element comparing to 16. So I'm going to insert the 19 here, and whereas 9, so 8 is not here. And then what is the element there in what I have done? 9, 8 and 7. So whereas 9 is the least most element, so I need to represent 9 here. 9. So and then 8. So and then 7. So this leads to 7. So this is the left subtree. So this is also my hierarchical structure. So you can understand this. Ishita, you understand? Have you understand this?
Ma'am, just a doubt. Why 13 is the left node of 12 and not
Because 13 is the least most element, then 16. Because it's when comparing to the root node, so 13 is the least most element. This is the least element, right? So I
Yes,
can't
ma'am, yes.
keep it here. I can't keep it here. This is the wrong.
Okay,
Okay.
ma'am.
That's why I put out a 13 as the right node of 12. So here the 19. So this is the largest element comparing to 16. So this is what the formation of tree. So any doubts with this formation of tree? Anyone having doubts? So whereas this having the addresses, that is points to the addresses, that is 1, 2 and so this having the addresses 3 and 4. So and this node having, so this 19 doesn't have the addresses because there is no element, so that is to be represented as 0, and this is also doesn't have the address, and this is also, this have the address 5 and 0. So that is a sequential, so address to be represented in a sequential manner. So because this is the paint, so that's why handwriting is too weak. So understand this concept, how we can create the tree and how we can represent the address. Understood? So if you any have having doubts, I can tell you once again. So no issues with me. So I can recall you once. No problem. So anyone having doubts to create a tree? So can we move on? Okay. So what is searching? So inside the tree, I'm going to search or finding the some value. So using that only. So using, while we are representing the least nodes into the left and the highest nodes into the right. So in that way only I'm going to search the values. That is, I'm going to search the value 9. I'm going to compare the value with 6. So that is with the root node. So 9 is greater than the 6, so it must be in the right. So also I'm comparing with this right node, so it is also greater than 8, so it will be on here. So this is the way. So this is the format for searching the values also. So while you are inserting the values into the tree, so this is the for in that way only we are going to search the values. That is what binary search tree does. And the finding the value according to the way you are inserting the values into the tree. Okay, are you clear? The searching, because the traversals will be different. The traversal is different, searching is different. Okay, according to this way, while we are inserting the elements, according to this way only we are going to search the values. Clear? So if you clearly understand how you can represent the tree, how you can build the tree, so then only you can search the tree. Any doubts, guys? Any doubts? Ishita, Kaushik, Abhijit, any doubts? Okay. So next move on to the traversal. So that is to be in DFS, that is depth first search and breadth first search. So DFS having 3 types of traversal, that is in order, pre-order and post-order. So whereas but first search having the only one traversal, that is level order traversal. So what is in order? So the in order is nothing but the traversal to be takes place from the left, root and right. Don't forget this. In order, pre-order and post-order. So in order takes place from the traversal to be from the left node and to the root node and to the right node. Okay. Whereas pre-order starts from the root node, left node and right node. Okay. Whereas post-order starts from left, right and to the root. Don't forget, it's too confusing, but you need to memorize here. So in order starts from left, root and right. So that is starts from left and visits the root and visits the right. Okay, we will see first in order. So how it can search. This is my tree. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are the elements are there in the tree. So I'm going to find in order traversal. So starts from left. So where is my left element least? So where the traversal starts from the top, so not from the topmost element, so it starts from the bottommost element. So that is what, whereas my left bottommost element is 8. So here 8, that is left, and what is the 8 root node? So that is 4. And then what is the root node for 4? And then 2. And what is that? This is what the left element. And what is the root node for 2? So I can't go to the root, is that middle element where I'm going to the right side. So 2, and then what is that left element again? So 9 and 5 and then 10. So up to this clear. So this is the left child. This left subtree must be over while reaches the root. So this is what the left, root and right. Don't confuse while I'm searching this left, you need to go this root node. So I need to finish up the left subtree first, and then I'm visiting the root node, and then I move on to the right subtree. So this is the traversal. Sir, can anyone define what about what apart from the 10 I need to go? So that is root node and starts from the right. So where it starts from? So what is the right node here? Right node element. Can anyone? So after this one.
11.
Yeah, so this is 11 and 12 and 6. No, I'm also confusing over here. So this is what the,
Sorry, my bad.
yeah. Why 6?
The left node is not there for the 6th node.
Yeah. So the left,
that's why it becomes the root node for it.
Yeah. So this is what, don't confuse. And then 11 and then 3. So 1, 6. So 6 is the address right here. So no, here this 6. So this 6. Don't confuse the address along with the node. So this 6, this is the left node. Okay, so this is what the right node. So this 6 and the 11 and again 3 and 7 and 12. So this is left, root and right. So you have to take part the left subtree and right subtree you need to visit. So I think much confusing this. So whereas I will remove this. This is. So I'm going to remove this all the addresses, then you can traverse the tree. Then you can find. So it starts from left, root and right. So left in the sense I need to take up the left subtree first. So in that left subtree, what is the bottommost left element? So that is 8. Okay, and then the left subtree, which is the left node, so that is 4, and here the left node is 2, and I'm going to the another left node, so that is 9, and I'm going to the right node, so that is 5, and then the 10. So this is what the parent, and I'm going to visit the root node. So this is my right subtree, where I need to, inside right subtree, I need to find the element over there which is in the left. So the 3 is having the left child, that is 6, and so there is no another left child for any nodes. So that is I'm traversing from the bottom right, so that is 11, and so and 11 I'm going to traverse. So this is what the right, and this is what the right, and this is what the right. So I'm going to traverse from 3, 7 and 12. So have you understood? Anyone got confusion over this? So traversal, you're having any confusions, because after the post order and pre-order you have to tell the traversals. You have any confusion in this in order? So where is the path over here? You need to complete, you need to finishes the all that nodes, that all the subtrees, then only you can move on to the next. So that is left, root and right. In the sense, I need to complete the left subtree and visits the root, and in the right subtree first I need to complete the left and then I move on to the right node. So that is what after 1 I move on to the 6. So because 6 is the left node of 3. Whereas other nodes doesn't have the left node. So that is what 6, and then move on to the right node. So that is 3, 7 and 12. Any doubts? Any doubts with this in order? If you didn't have any doubts, just inform there is no doubts. Can we move on? Can we move on, guys? Are you there? The people are you there? Abhijit, Babina, are you there?
Yes, ma'am.
What happened then? So if you can clearly understand, means you can tell, is it fine? But if you're not able to understand the traversals, you can tell me, I will recall you. I will sorry, because you are the one, you are the guy we are going to tell the another traversals, that is pre-order and post-order. So pre-order, what it starts from root, left and to the right. So can anyone tell me how it starts from? So I'm just deleting this addresses. It's confusing. The address is too confusing. Whereas anyone can start. What is the left node? Sorry, starts from root node. Anyone answer me, please? Samanu, Mohammed Jain, Richard. Anyone answer? What is the root node? First, I'm going to traversal. Okay, I will start here. So that is 1 is my root node, and so after root node, so that is the left and to the right. So I need to finish off the left subtrees. So that is what. So left is the 2, for 2, another left is the 4. So for 4, another left is that 8. Okay, up to this finished. So and then I move on to the right on the left. So that is 2 after this. So 2 is initialized. So that is 5, and then 9, and then 10. So this is over. So the left subtree fully over. So then move on to the right. So in that right, I need to fix the positions that is being in a left first. So that is 3. So I'm going to take the left first. That is 6 is the left node taken here, and there is no left node for other childs. That is why I'm taking. So other right nodes, that is 11 and 7 and 12. So this is the way of traversing using this condition. So while we are going to this post order, that is left, right and the root, at last the root. So left in essence, whereas I need to traverse along with this left nodes and to the right nodes and to the root. So whereas my first left node is 2, and here the left node is 4. So left, right and root. So node, so that is to be traversed from the bottom. So that is 8. So that is 8 is my last node. So and then 4, and then the 2 is my left node, and then 2, so, and then 9. So after 9, what is the element there be in the left? No elements. So and then move on to the right here. So 10, and then 5. So that's it. So this fully over. So and move on to the right position. So here the right subtree. So move on to here. So whereas in that right, in the right subtree I need to fix the positions in the left first. So where is the left element over here? So 6 is my left element. So I need to traverse over this 6, and after 11, and then 12, and then 7, and then 3, and last node is 1. So I'll go through these parts. So a little bit confusing because we need to visit using this left, right, and row inside the subtrees also. You need to visit over there. So they just representing the address because you need to find the left and right. That's why they are representing the address here. This is the 3. So you just clearly understand that what is in order, what is pre-order, and what is post-order, because these 3 are the most important questions. That is way of traversing from pre-order, in-order, and post-order. So which we need to do. So that is in-order starts from left, root, and right, whereas pre-order root, left and right, and post-order left, right, and root. So don't forget this. So the way of traversing, if you have any doubts. Any doubts, guys? Just please be active as
No,
much.
ma'am. No, ma'am.
I understand your situation, but you need to listen, right? So and the 2 more terminologies we need to define. So that is height, and another one is depth. So what is height and what is depth? So height is nothing but that is to be calculated from the root to the deepest node. So that is starts from, so that is starts from the root and to the deepest node. So we are going to calculate the height. So this height of the tree is, that is, this level is calculated to be 1, and this level is to be calculated as 2, and this level is calculated as 3. So that is to be topmost, that is from rootmost element to the deepest node. So from 0 to 1 we can calculate 0, 1, 2, 3. So the height of the total tree is 3. So this is what the height calculation. And next one is depth. One more thing is depth. So depth we can calculate it from here. Here it is not mentioned. So here it is to be calculated from the deepest node to the root. So that is also will be the same. So that is you need to calculate the edges along. So that is 1, 2, 3. So edges also will be 3. Height and depth will be same for all the trees, but the calculation will be different. So for height you need to calculate from root to the deepest node, starts from 0, whereas depth to be calculated from the top node, that is least from the height node. So that is to be calculated by the edges. That is to be, you need to calculate the edges, that is 1, 2, and 3, the level of edges. Here you need to calculate level of nodes. Don't forget, height is the calculation of nodes, whereas depth is the calculation of edges. Edges is nothing but the connection between the 2 nodes. Okay, and so we need to see what is level order traversal. So level order traversal, that is that with the first search. So level in the sense you need to traverse with according, there is no root, right, and left and all. So that is from starts from level by level. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is, it is the easiest way traversal over here. So that is starts from 1. So you need to start finish this level and move on to the next level. So it doesn't prints that left, root, and right and all. So this is what the level order traverse. So this is the birth first search. So whereas DFS calculates in order, pre-order, and post-order. Don't confuse. Level order traversal is the birth first search, whereas DFS is the in order, pre-order, and post-order. Clear the definitions. After this, definitions are all over. So what is binary tree and what is binary search tree, and what is BFS and what is DFS, types of DFS, and we have implemented a tree. So using that left least node and the highest node, and we have found the height, and at last we have seen what is level order. So are you clear? So any doubts with this basic definition and all? Guys, any doubts? If you're having any doubts, if you're not understanding anything, you can ask me here, because this function is not understandable and this property is not understandable in the sense, you can definitely ask. I'm here to rectify your problems. Any doubts? What happened? Guys, are you there? Are you feeling sleepy? Because one more session is finished. So next we are moving on to the program. I think it is too sleepy when we move on to the program. So can we have a small quiz here? So for 5 minutes to brisk up yours. Can we have a small quiz? Just tell me the answer. Ishita, Kaushik, what happened? Are you clear cut? Understand the definitions and all?
Confusing.
Confusing. Where it is confusing? The traversals or all the topics?
Traversal.
Traversal. Okay, I will clearly inform you. Wait a minute. So if you're guys confusing in the sense, you can feel free to ask me, because no issues over there. Okay. And can anyone tell what is in order? What is in order? Just tell me the
Left, root, right.
yes. Okay. Okay. So this is my tree. So this is my tree. So whereas in order travels from. So everyone need to active, because if you not understand the sense, you need to be active. So that is left, root and right. Okay. So where is my, I need to traverse it from the bottom. So that is from the bottom. Okay. So left, so what I just memorize it here itself. What is the traversal for in order?
Left to right.
Yeah, left, root, right. So here, where is the left element? From the top, from the bottom, what is the left element?
4.
Yeah. 5. So 5 is the rightmost element here. Okay. 5 is the right node of 2, right? Yeah. Okay. And then what we need to do? Left, root and then right. So it is finished. So 4 is finished. So what is the leftmost element here in the left subtree? This is what the left subtree, and this is what the right subtree. First I need to finish this, then only I can move on to this. Okay, this is 4. And where is the left node here? What is the next left node here?
2.
Yeah. So I need to finish. So here there is no left node elements. So directly I can move on to 5. So this is the only one element left there in the tree. So the left is finished over there. So left node is fully finished. So I got it. So and then move on to the root node, right? So left, root and then right. Am I right? So this is my in-order traversal.
Ma'am, you did left, right, and then root.
So in that left, in the sense, I need to finish all over the left nodes in that left node. So I need to take up this. So you just clearly understand the condition. So where I need to wait. will enlarge this one. So whereas this is my tree, this is 1, 2, 3, 4, 5, 6, 7 is my tree. Okay. So whereas this are all what? And left subtree. This is to be called as left subtree. Okay. So this is my root node. Okay. So this is my root node. So this is what the left subtree and this is what the right subtree. So if you are traversing through any traversals, you need to finish the subtrees first. So this is what the left subtree. So if you are going through the in-order traversal, so you need to finish this left subtree first and then you are going to the right subtree. Okay. So this is what I am taking. So for in-order, I am taking this 4. Are you clear why I am taking 4?
Yes.
Okay. So then what is the next left node here? So 2 is the left node of 1, right?
Yes, ma'am.
So that is why I am taking 2. So any left nodes in the left subtree? No. So then I can move on to the right node. So because I need to finish up this first, this left subtree and then to the root and then I'll move on to the right. Clear?
Okay.
Okay, then why? So the remaining element, so 2 is finished and 4 is finished. What is the remaining element over there? So that is 5. Because the 5 is the left subtree of the root. Because this is the right node, but 5 is what? It is the left subtree. So it holds the position left subtree. Okay, that is why. So this has to be the left. Okay, so then I am taking the 1 as a root node. Okay, then I'll move on to the right subtree. So inside the right subtree, so this is what the root, and inside right subtree, so I need to hold the position from the left itself. So in the 3, 6 and 7, what is the left node here?
6.
Yes. And any other left nodes is there for? No. So I can move on to the root node. What is the root node for 6 and 7?
3.
That is 3. And then the right node. Understand? Why I have done this? Understand? So any confusions over there with this in order? Just if you didn't understand, I am here to explain you 100 times. No problem. So but you need to understand what is going on.
Let's say
one more
six.
time.
Yeah, sure.
After 6, why we took 3? That only.
So after 6, why I did just take 3. So 6 is the what element? 6 is the leftmost element of 3, right? So this is what, this is not confused. Okay. For that is what I have taken 6. Okay. And there is no left subtree for, so there is no left nodes here for this right subtree. There is no left nodes apart from 6. Am I right?
Yes, ma'am.
So then we are moving to the, what is the condition for in order? That is left, root, and right. So this is the condition, right?
Yes, ma'am.
So left is over. So there is no left elements in this node. So where I am going to take root node. Yeah. So what is the root node for right subtree?
3.
3. So that is why I have taken 3. And then I have taken this right node as 7. Clear?
Yes.
Yeah. So this is what the function. So any others having any doubts?
Yes, ma'am.
Clear?
Hello?
Yeah.
Yeah. Let's say if 6 is not the leftmost node. Let's say there was let's say 3 and 5 are there as well for 6. 3 as a left node and 5 as a right node of 6.
Here, 1 is the root node. So 1 having 2 children, that is 2 and
No,
3.
that's, ma'am.
No, ma'am, he's saying another case, ma'am. For example, if we have 2
Example
nodes for
case,
6.
Okay, for example, so what is it? You just create a tree.
No,
Creating
this like this from this tree itself, ma'am.
okay, in
I
this
want to
tree.
add 2 things. Yes. Ma'am, at 6, add 1 left node and 1 right node for 6.
Okay. So that is 8 and 9. Okay, clear?
Okay.
Mm.
Then, ma'am,
So,
from here, so we started 8.
mm.
So we 8, 6, 9, 3, 7.
Yes, so what I'm going to represent, so what I need to represent here in the sense, so same for this left subtree is finished. So here I need to start from 8. So just tell me, starts from 8, then what is the next element?
Then is the root.
No. So this is the left element, that is 6. That is not a root. So that is the left child, that is 6. This is because 6 is the left child, right? Left child for 3.
Okay.
Yes.
That is 6. Oh, correct. So left is finished over there. So any left nodes left here. So any left nodes is there in this tree, in this overall tree, in this
No.
tree alone. No. So whereas I need to go on to the root node. Okay. So what is the root node over here? So 6 and 3 are the root node. So 6 is there and I'm going to represent 3. Am I right? Is it clear?
Okay.
Yeah. So then what is next? What is next? That is
The
right.
node.
Yeah. What is the right node? So 9 and then 7.
Okay. All right.
Clear? So that's it.
Okay.
So you need to follow this condition for every subtrees. Okay, that is left, root, and right. So I will create another tree. So you guys need to tell. So that is for pre-order and post-order. Okay. So that is 1, 2, 3, 4, 5, 6. So that is 1 is the root node. 7, 8, and 9. Okay. So this is what left subtree, and this is what right subtree. Okay, what is the pre-order traversal?
5, 4, 2, 6, 1.
So no, I'm just asking what is pre-order traversal? That is root,
Root left, right.
yeah, root, left, and then right. So that is, what is the root element here?
1.
1. So what is the left node? So left in the
2.
sense I'm going to take this all. Okay. Simply you can take this. Okay, what is the next element I'm going to add?
2.
So you can start from bottom.
Okay.
Okay.
5.
5. Yeah. Then what is the next element?
4.
Yeah, this is not element. Okay. So what is the next element after 5?
2.
What is the next element after 5? 4. 4. Because 4 is the left element. Clear? And then 2. Clear?
Yes, ma'am.
Yeah, because 5 is the left element and 4 is also the left element, 2 is also the left element. Okay. So then 6. Is it clear?
Yes.
Yeah. So then I'll move on to the right. So whereas right, so which is be the root node?
3.
3 is the root node. Yes, yes, yes. Yes, sorry guys, I made this mistake. Sorry, I made this mistake. Whereas traversing with anything, so you need to start from root, right? So 2 is the leftmost element as well as the root element. So first we need to start with root, left and right. Correct? There is root and 4 and 5 and 6. So clear why I am representing this? Some guys said, so that is the answer. Why I am representing this clear? Because traverse is from what?
Root, then left, then right.
So I have taken the 1 as the most root element. So for this subtree, which is the root element?
2.
2 is the root element. So this is also to be the left subtree. Okay, that is fine. And 4 is the next root element, also will be the left subtree, that is 4. And 5 will be the root element, next left element. And then I have taken a 6. Okay, clear. So any doubts with 2, 4, 5 and 6? Any doubts?
Yeah.
Yeah. So and then move on to this right subtree. So where I need to go on to the right. So first I need to write 3. What is the next element?
Then yeah, 7,
Yeah. And next
9, 8.
root. Left node is not there.
Ma'am, won't 8 be the root, ma'am?
Yeah, 8 is the root. So I need to first 8 as the root, and then 7, and then 9.
Then 9.
Okay. So for every subtree, you need to find the operation. But this is 7. Okay. And for this also, can anyone find what is this is what pre-order in or post order? So this is pre-order or post order. This is pre-order or post order.
Pre-order.
Yeah. What is the post order traversal then?
Left,
What is
right, root.
okay, left, right, and root. Can anyone represent the path for same tree? What is the left node?
5.
So overall left node. So we can take it from 5. Okay. What is the another left node?
4.
Yeah.
2.
2. And then 6.
Then 1.
1.
No, 1.
Yeah, correct. 1. So this is what this left subtree is over. And move on to this right. So I'm going to traverse from left, right, and root. So what is the leftmost element here?
7.
7.
And
And
9.
which is 3. So these are 3 will be the 3
Right.
rightmost elements. Okay. Yeah, 3 rightmost elements. So that is we can traverse from left, right, and to the root. So this is what we can traverse from 9, 8, and 3. Clear? So this is the
Yes.
rooster.
Comes at 2 or 3, ma'am? 5, 4, 3 or 5, 4, 2?
2.
5, 4, so 2, 2. This is 2. 2. This is 2. 5, 4, 2, 6. Clear? Any doubts with this traversal?
No, ma'am.
Others? What about others? Some of them only, maximum 10 of them only listening this class. What about others?
Ma'am, one will be at last, no, ma'am.
So sorry.
One will be at last, no, ma'am. Left, right, root.
Yeah, left, right, and root.
You wrote one in
Yeah.
middle.
Sorry. Yeah, this will be right. Yeah. So correct. Absolutely. Thank you for your correction. Absolutely. So this will be at the end. So so this is too confusing, guys. So you need to clear. So which one will be the first and which one will be the next? So any errors over here? Nothing is there, na? So can we move on to the program?
Yes, ma'am.
Ishita, have you understand this, or else it's too confusing now?
I need some more time, ma'am. But I understood what you're saying.
Yeah, so you need to find this calculations, but these calculations you need to operate it for every subtree. So you need to separate this like, so that is left subtree and right subtree. For every trees you need to do this operation. Okay, you just do it in your home, and you can ask me tomorrow. I think tomorrow classes there.
Yes, ma'am. Many classes.
No, I am asking this training.
Yes, ma'am. That also 6 to 9.
Yeah, 6 to 9. So after that, so Friday is there.
No, ma'am. I don't think so.
I think tomorrow is the last class. I think so. So Ishita, so you just do it in your home. Okay. Likewise, you can separate these trees, and you can traverse using this way, and then inform. So you need doubts, you can ask me. Okay. Okay. So move on to the program. So like Dynamic programs is also there here today. What is binary heap? So just understand this. What is binary heap? So binary tree heap is a complete tree. So complete tree in the sense all will be level equally. So that is so this is not a complete tree where I have drawn. This is not a complete tree. So complete tree in the sense this every node having equal number of children. That is 2, 3, and 2 having 2 number of children, 3 having 2 number of children, and 4 having. So the level must be equal. So the level also to be equal. So here another node is there. So this is what the complete tree. So all levels of binary heap or except possibly the last level and has the key left as possible. That is what they said. So the level for all the trees must be equal. So that is said to be the binary heap tree. Binary heap is nothing but it is the complete tree. So that is having the levels equally. So this is also the example for binary heap tree. So the levels also to be equal. So if the node 10 is not there, it is not a binary heap tree. So it can either be minimum heap or maximum heap. So minimum heap in the sense it may be this within this level. So that is 0, 1 level or maybe the 2 level. So any levels will be there, but the levels must be equal. So that is what minimum or maximum heap. So where we are using, so we can't the same property we are using for keeping this minimum and maximum heap. So just know the thing what is binary heap. So it is also the tree that all the levels must be same. So this is what binary heap tree. And move on to the traversal program. So that is implementation of tree traversals. It is too easier than stack, queue, and list and all. So that is tree traversal we have seen today. So I'm going to create a class node. So that is class node. So I'm creating the structure. So this is what for linked list I have created the structure, right? Same as like I'm creating the tree structure here. So for tree structure, so that is key is nothing but a node. So that is the value we are going to add. So that is what key and left subtree and right subtree. That is left node and the right node. So this is what I'm going to public node. I'm declaring another class constructor that is public node int item. So item is nothing but a key value. So where you're going to fix the values, that is what key is equal to item. So this is what the constructor, and I'm declaring this left and right as null. Okay, same as like structuring of the linked list. So we can structure this tree also. Okay, so inside this I'm going to traverse this key. So in that main function only you can add the items, that is main tree is equal to that is tree dot root and tree dot root dot left of, you can add the nodes. Before that we will see what are the functions we are going to see. So the functions is like void print order and print pre-order, post order, in order. This three methods we are going to see in this main function. So class main is my main class. So inside this, that is post order, pre-order, and in order. So inside that I'm just calling that my method, that is print post order of root, print in order of root, and print pre-order of root. I'm calling this method. So what is the value inside this print in order of root? So I'm going to declare. So before declaring this, I'm going to declare. So that is I'm declaring the tree, right? So that is tree. Tree is my subject, so sorry, object. So this is for object I'm creating the root, that is tree dot root. My one is my root node. So that is tree dot root dot left in the sense. So for first node, so for first tree, so my left node will be the 2, and tree dot root dot left right in the sense the 3 will be the right node for 1, and tree dot root dot left in the sense, so left in the sense for what is the left node for 1, so that is 2. For this 2 second node, that is having the left node, that is 4. So that is 1, 2, 3, and 4 will be the left node of 2. And what is that tree dot root dot left dot right? So and then it will be 5. So what is 3 root and left and right in the sense 4? So that is 4 for children for 4 is 5. So this is what the arrangement is, fixing the nodes. So this is the one way. So is it confusing? So it is nothing but object dot root dot left or right. You need to fix the position. So like this. So this is my root. So root dot left in the sense this node, root dot right in the sense this node, root dot left of left in the sense for this left node I am assigning this another left value, and root dot left dot right in the sense for this root, this is my left and this is my right node, I am assigning the values to here. So root dot right in the sense this is the right node, root right of right in the sense for this right node I am assigning another right node, that is 7. So this is what they have mentioned here. So this is confusing. Is this confusing?
Ma'am,
And
is
where
it
we define
following
the dot left and dot right?
Because for creating the tree, so inside main function, so if you are declaring into the stack, what you are going to do? So if you want to insert the element into the stack, what you are going to do? That is stack dot push or stack dot add. So likewise, you can mention the methods, right? Am I right? For inserting the elements into the any stack or queue, so what you will do? So that is object dot, that is list dot add of, list dot add of, list dot delete of. So likewise only you can put it, right? So yesterday we have seen the program. I will show you. So likewise we have added the elements into the queue. That is queue dot add of, queue dot add of 2. Likewise we have added. This one clear? So for this queue object, I am adding the values. I am adding the values into the queue. Is it clear? So I am asking this queue adding is clear? Is it clear with this queue adding and some on one more by
yes,
asterisk?
ma'am, this I know.
This is clear, right? So same as like I'm going to create an object for this main function, that is main tree. So tree having this is not a sequential order. So this is the hierarchical action. Hierarchical order. So this is not in a sequential manner. So that is what I'm representing. So before that, I need to represent here. So that is why, so this is the representation I have represented in another method. So just I'm calling this methods tree dot root of, that is root node is 1.
Ma'am,
The
is it not
representation,
following the rule like the one is root and two is greater than one, so it should be on the right, but you're putting it on the left.
no, this is for traversals. That is why I'm declaring the element. So I'm just declaring, I'm just adding. This is one of the what we can say. So while we are formatting the trees, it will be put up like this. So this is that what I say. This is not the default one. This is not a default one. So just inside the queue also I'm adding the element. So this is not a default one. So just I'm adding the elements. I need to check the elements where there is a maximum element. I need to check the elements where there. So if I'm inserting the elements wholly, the format of the tree will looks like this. Whereas this is not a structure of the tree. So just I'm adding this element here itself. But if you are using the tree in a real time, so while we are sequentially inserting the elements, the tree will looks like this. That is in the least order in the left and highest order in the right. Are you clear what I'm explaining now?
Okay,
So if it is in a real time, it is declared will be like this. The declaration will be like this. So, but I'm going to check the traversals. So for checking the traversals, I'm just creating that sample tree. This is the sample tree.
okay, ma'am. So this doesn't follow the
Yeah, it
actual
doesn't
structure.
follow. Yeah. So this is my formation. This is the tree formation made by the human itself. So it is the function made by me.
Okay, ma'am.
That's it. Are you clear? So some of the one more boy, person that is asked me, Kaushik. Kaushik asked me. So where we are using the tree in real time, can anyone guess it?
So Magnus is like employee hierarchies.
Hierarchies.
File storage.
With storage?
File storage in our computers, which are basically under a folder. There is a folder.
Definitely. And the producers and consumers like the like you can see the example like the Sensex and all. So it will be looks the highest topmost value. It automatically arranges the elements from the topmost to the least to most. So this also follows real this trees and all. So the Sensex data, these all the real life applications. Facebooks, and if some of them said Facebook, and I didn't know where the Facebook uses the tree structure. You can find out Any Facebook application that uses the tree structure?
Yes, ma'am. The friend system is tree.
Friend suggestions, like likewise Cecil, and most of the Google Maps uses the locations that uses the graph theory. Actually, the Google Map is the example for graph theory, but whereas the Facebook friend suggestions uses graph theory concept as well as the tree concept. Likewise, someone said, sorry, my colleague said. So any application that uses tree concept? So that is
Chess,
mostly used. Chess, yeah, chess is used, and mostly databases. Most of the databases uses, that is for producers and consumer databases. You can see now, if you are doing the application, so in that application they uses the tree concept, the producers and consumers. So the least to most producers and least to most highest producers, and which will be the highest consumers. So this will be the main real life example we can see in tree. Okay, so if you are reaching the career, so you can know that. So that is consumer products producer problem is also there, the consumer producer. So in the tree itself the problem is also there. So that is one of the real-time example, and chess is also the real-time example. So we can see the chess also. So why you can, so this is what I'm just defaultly adding this tree. So likewise stack and queue. Okay, this is not a original structure, so I'm defaulting adding with the implementation of this method. So for this I'm going to implement this method. So that is why I told this main function first. So I'm declaring, why I'm declaring node dot left, node dot right, that is here. Okay, so I'm declaring, so I need to find the traversal, that is pre-order, in-order and post-order. So three methods, that is void print post-order and void print in-order and void print pre-order. So I'm going to find these three functions. So before this I need to find if the node is null or not. So node in the sense, if the tree is null it doesn't return. So likewise I need to check whether the tree is empty or not, and then I'm going to print the value, that is print post order. So what is the post order functionality? What is the post order traversal?
Left, right, root.
Yeah, so that is what node dot left, node dot right, and then root in the sense, that is the key value, node dot key, that is what the key value. So it prints. So likewise same as in order, so I'm printing this node dot left and the key, and that is the root, and that node dot right. So key in the sense, that is the root, so that is the key is the item. Okay, and node dot keys, that is the root, and it returns the next element. So whereas what is the traversal for pre-order? What is the traversal for pre-order?
Root left.
Yeah, root left and right. So that is what node dot key, I'm printing the root and left and right. So that inside that main function I'm just adding the nodes, I'm printing this in order, pre-order and post order traversal for this nodes. So I can run this program also in Eclipse. I'm creating the new class. I'm just copy downing the program because another 3 examples is there. I need to fix up this also. My class is T. It is one more error. So it finds that output that is in order, pre-order and post-order. So that is why I have made this sample tree. So from the sample tree, so that is in order from left, root and to the right. So pre-order, so that is root, left and the right, whereas post-order, so right, left from the root. Sorry, left, right from the root. So okay, are you clear? So are you clear with this program? This is a simple program. So whereas the example of the programs will be behind here, it must be the largest things we need to find. Whereas this one of the tree that is given, I'm going to given in a program. So this is my tree structure, that is what given in a program. So I need to find sum of all elements in a binary tree. So this is what a binary tree. So I need to find the sum. So find the sum in this, and that is 15 plus 10 plus 20, 8 plus 12 plus 16 plus 25. So this is what the sum I need to find. Okay, so this is what I'm going to create a structure of the tree before that. So just I'm going to write the lines one by one. So if you are having any doubts with any line, you can ask me. So any doubts with any lines, you can ask me, guys, because that's why I didn't explain this pre-order program there. I'm going to explain here. So for inside the class main function, I'm going to create a structure of the tree. So that is static class. I'm going to create another class that is for structure. So this is what for creating the structure. So someone said I didn't know the functionalities. So here I'm going to define this functionality for separate functionality for every methods. So just clear cut, understand this. So node, so this what the structure I'm calling is node. So inside I need to represent that is key values, that is for root, and the node class name right and left. Okay, so inside that I'm going to define the constructor static. This is for the constructor, static constructor. So I'm creating for the class node int. So I'm creating the object that is node n. I can't give n because I have initialized n here, that is n1 is equal to new node. So this is the subject I'm creating. This is the sorry, object, not a subject. So object creation for the class node constructor. So that is I'm referring these variables, that is n dot is equal to so I can simply define this also. Likewise also I can define it. So that is key left and right is equal to null. So key is equal to item and left and right is equal to null. Likewise also I can define, and I can define some other variables. With that also I can define it. So likewise n dot key is equal to key. So when I have initialized that integer keys, that is what. So this is n1. n1 dot left is equal to n1 dot right is equal to null. So the left and right node will be null. So what happened? Left is equal to n1 dot right is equal to null. Okay, that's it. So I'm just returning, this is that static function. So I'm just returning this node n. Up to this clear. So this is what structure defining the structure. So this is also the one of the method defining with another variable. So I need to, so in the PPT, so same, the declaration is for same variable, that is item. So this is the one of the method, and this is for the another method. Simple difference is the use of constructor. So this is what creating the structure of the node. Okay, so and I'm going to add, so I'm going to create a method for finding the maximum element. So that is what the program is for, finding the maximum element, right? So that is what I'm going to write create a method for sum of elements. So that is static. So sum, in the sense I can simply take it as integer. So integer, I can name it as add. So for which node I'm going to add, so that is node, and I can call it as x. X is my root node. Okay, so inside this function, if x is equal to null, so it can't go through the function, it returns 0. So my function x is null, in the sense returns 0, else it returns x dot value of what the list element I need to add. So that is add n dot key and sorry, x dot left element, and I am going to add x dot right element as add dot right.
The method n basically creates a new node, right?
Yes, this n, right?
Yes.
Yeah, so this n creates the new node. Yeah, so for new node, and I'm assigning all those variables, that is n1 dot key, n1 dot left, n1 dot right. So I have assigned. So if you can, sorry,
Couldn't you just use a constructor instead?
yeah, we can use. So that is what I have said. So likewise, also you can use this method also, and
Okay.
also you can use this also. So where I have used this, so that is why I didn't created the constructor there. Okay, so we need to find a different ways. So that is what I didn't use the constructor there. I'm going to add, so I'm going to add this key value plus left child plus right child. So this is what the function does. Function finished. So this is a small function to add the values. That's it. So add, in the sense I'm just creating the method. So inside add method, so I'm just adding the values. That's it. Simple program. So inside that I'm going to create a 3, that is public static void main. Inside this I'm going to create a object for node. So this static object for this node, I'm going to create an object. So that is node is equal to node of 1. So whereas I can add this 1, 2, 3 as the input. So whereas I have declared node x here, so I can take this element. Root node is root dot left. This is what the root node. Why is showing the error? Root node is x is equal to null. I have initialized, right, node of root. We will see. is x dot left I'm just declaring a tree here. So x dot left tree and x dot, this is what the right node, and x dot left, so this is what the another left child. So this is what left dot right, I can take it. This is left dot left or right, anything you can put it. 2 4 5 there in a program I need to define the sum. The sum is equal to, so the method I need to call, that is add of x.
Also, new node if you space, right?
Yes, wait, I'm seeing this only. At last we will rectify the error. So this is what not a object creation, so I just adding the node, whereas like this. Okay, need a object. I think this will be the correct one. Wait, we will check it. So I can initialize another x1 here. Okay, we'll just finish up this program. System dot println it calls the function. So what is that? So where I have created new node, that is not created any new node, so I can call it as n. Yeah. So because I need to call this function, because so where new node is the function, that is what where I have declared this node. Sorry. So with that object also you can declare it. So where I made this mistake, so this is n where I have initialized the static node here. So this is what I can call this method. So you can call this method directly without creating an object. So this function, so this program where I didn't create an object for the main class, but I have called this static class. I think I just called this static class. Are you clear what I have mentioned? So this is not an object creation, guys. This is, I didn't created any object. So this is the program that I have created an object. So that is with that object I created the node. So that is tree.root, and this is also the another method without the creation of object. So that is node, I can call the main method, that is class name, main class name with that x variable. So I can calling this function, so that is the static function, that is node n. So I called this function directly to assign the values. So where I print this, I run this program. So sum is 21. So that is 1 plus 2 plus 3, 6, 6 plus 4, 10, and 10 plus 11, 21. So clear what I have done. So I just made a change over there. Didn't created any functionalities. So didn't created any main functions. I statically over called this method, this node n. Just I clear this program. Clear. This is a simple program. Clear. So just I have created two methods, that is for structure and that is for add. I have created the another, that is not a constructor, this is also another method. So for declaring the values, whereas this method I called here for inserting the elements into the root, that is into the tree. So it defaults tree will be added, it this elements to be added by this method, and it is done. Okay, clear. So this function, that is int sum of add of x, in the sense add is the function, one function that goes to here. So this return statement will be take up on this, and whereas x initiated, that is that node x. So where I have initiated the values in the x, so it calls here. So where it return, this return function adds the value, that is 1 2 3 4 5 6. Any doubts, any confusion, because I didn't created the main class object. I think if you
add function, ma'am, the static one, right?
Yeah, it's a static one. Yeah, this is what.
That's it.
This is what. So add is also the static, where I have created the another method apart from the constructor. So I didn't created any constructor here. So whereas I have created the another method, so I'm just called that method directly into this main function without creation of objects. So this is what that different program. So without the creation of constructor, without creating any object, I'm calling the static methods directly into the main function. That's it. So we need to understand this two static methods. So this is what the simple program. And what is the next program they have given? So only 1 hour is more. And do you guys know what is predecessor and successor? You guys know what is predecessor and successor? Have you studied anywhere?
Predecessor comes before, successor comes after.
Sorry, predecessor
Comes before, the successor comes after, right?
Yeah, so that is the normal predecessor and successor. So in tree we need to find the in order predecessor and in order successor. So that is what the sum of it. So the sum of it in the sense, so predecessor, as you said, so it comes before. So where we are taking the node, so that is what in the node lies behind of the given node, and successor in the sense that the node lies ahead of the given node. So that is behind, so that is before and after. So that is predecessor and successor. Whereas we need to find the predecessor and successor for the given tree. That is, this is what the input, and I need this output, that is 11 9 13 2 4 and 3. So how it comes? So for 1 I need to find the predecessor and successor. So what is the predecessor for 1 and what is this successors for 1 element? So predecessor for 1 is, yeah, tell me.
Predecessor would be 0. Means nothing is there. But the successor could be either 2 or 3.
No, so we need to find in order predecessor, in order successor.
It depends on which order you're going in the left, right node, or
Yeah, left right node. So which is depends on the in order. So which is depends on the in order. So that is for 1. So the in order is that 5 is the predecessor element and successor will be the 6 is the successor element. So that is 5 and 6 will be the, so that is in order how you can traversal. So that is left, root and right. Am I right?
yes.
Yes. So that is for left, root and right. So whereas 5 in the sense, this is the 5, and also we need to check the value of the highest value in the left node and the right node. So that is what the predecessor takes 5, that is highest element in the left node, and 6 is the highest element that is in the right node. So that is for root node alone. We need to check along this because the root node doesn't have behind the items, there is more elements is there. So it checks the elements like this, and for other nodes we need calculate the elements like that is for 2 and 3. So what is the predecessor for 2 and what is the successor for 2 and 3?
Predecessor is 1 in both cases. Successor of 2 is 4, successor of 3 is 5. Sorry, 6.
But so here 2, what they said 9 will be the predecessor. So because both will be the nearest element, that is 4 and 5. So we need to add. So we need to add this predecessor and successor here. So that is the sum of predecessor and successor. That is for 4. So they have calculated for the main things. That is main root node alone. So for this leaf node and the root node only they have calculated. That is 1, 4, and 7 they have calculated here. So that is for 1, the predecessor will be 5 and the successor will be 6 and the sum is 11. And 4, there is no predecessor, that is 4, there is no another nodes behind there, no predecessor, that is only node is there, that is 2. And 7 also there is no nodes is there, that is 3. And that is 0 plus 2, it is 2, and 0 plus 3 and it is 3. So that is for 4 and 7. Okay, so we need to find the in-order predecessor successor using the program, that is using this binary tree we are going to create it. How we can create it, that is the program we need to see. Anyone tell me how we can create, what is the first step we need to do? I'm going to create a program. So for finding in order and pre-order successors, what is the first step? As a type of linked list. One
Define the
for every.
nodes and everything in the starting.
Yes, that is the to define the structure of the nodes. So inside this class, I'm going to create a static class. We can I can name it as key left comma right. So inside I'm going to create another class, that is static. So this is not a constructor also. I'm creating another class with the name, I just keep it off n. I can represent data here. Sorry, I can represent key here. So that is key is equal to, so I can't declare anything here, that is I can declare anything, that is key is equal to something k, and k is equal to key something I can declare. So this is also one method. So without declaration of any arguments. So without declaration of any arguments like this, I can simply declare like this, that is node x. So without the declaration, I can simply put that key value here itself. So I am going to write a function after declaring that object and all. So function to get the new node. So that is static. So I am going to find a predecessor. So static node. So get a node of. So this is what the function to find the new node. So get node of values. Here I am going to allocate a here allocate a node. So that is for I'm creating an object, that is node n is equal to new node of add return statement. Okay, we'll add it after that. Okay, putting into the data, that is I'm going to add a data, that is n dot key is equal to some key values I'm going to prefer, and n dot left is equal to n dot right is equal to null. So this is what some declaration, and return n. Okay, so here after this method ends, I'm going to write the function for in-order traversal. So that is, so I need to find the in-order successor and predecessor, that is static void. I name it as in-order. So here I'm going to call the node root. So here I'm going to create a vector. So why we are creating the vector? So that is why I'm creating the binary tree object. So I'm going to find the predecessor and successor. So that is what I'm creating the vector here. So that is vector object, vector of integer. I can declare any method a. So inside, if root is null, so return something, and in order. So what is the in order function? That is left, root and right. So I'm going to return this. That is in order of root dot left, comma, what the object, vector object I have created, that is a. Same is like in order of root, comma, that is key value, root value. So here I need to add something, that is right, comma, a. So here what I need to do this type to missing type vector. Okay. So here I need to remove. So like I need to a dot add of, that is I need to add the root element, that is root dot key. Okay, so this is what the in order functionality, that is what I have. Okay, so in order functionality, that is in order and the root, that is left, root and right. So this is the in order method, static method. So that is root starts from the left, root and right. So I am going to replace, that is find the sum of predecessor and successor value. So I'm going to sum this using this node. So for this I'm going to create another method, that is static void. So this is what sum elements, that is I take it as sum node of root, comma. So likewise I can take another integer, vector integer, that is a, and so inside this I need to check as like if the root is null or not, same as like I need to check, and I need to find the sum of for this pre-order and pre-order, in-order and post-order. So I'm copying the same thing, I'm routing inside this method also. So I need to check root is equal to null or not, and recurs from the left child. So it starts from the left child. So here I need to replace the function sum. So root dot left, that is vector integer a, and another integer I need to add. So I will check this. that is root dot right, a, that is sum. So I need to add some other element I. So why I am adding this I? So I'm moving the pointer to the next element, that is next to the successor, that is initializing as int I. Capitalize. So where it is to be a comma, I checks this methods and replaces the nodes with. So what it does is the replace the nodes with the sum of its in order and successor elements. So this is what I need to take this element. So I'm going to add this, that is root dot key is equal to a dot get I dot. So where the data to be taken from the root element, so data -1, and this is what the condition to check. So a dot get dot data, so +1. So here the condition to be represented in the program 2. So where it is like for pre-order and in-order processors. So this is what the array size we need to represent. So that is for increment, decrement the elements. So that is initialized 1. So this is what the approach. So that is what I forgot to say this. So for in-order and pre-order traversing the nodes elements, I need to represent the array. So this is to be incremented and while the initializing the I value. So this is what I have defined in this program. So that is I is equal to, that is initializer of I. So I need to incremented and decremented over here. So I can increment the I value here. That is I dot data plus. So this is that one of the main rule to declare a program. So here also I need to declare the I value. So after this, what is the error showing? Create class integer. Okay, we'll take it at last. So it is a primitive data type. After this, I'm going to create another method, static void sum1 root. This is the utility function. This is the sum1 is the utility function to replace the each node in a binary tree. So that is to find the sum of its pre-order and in-order functionality. So this is what the utility function where I have created, that is sum1 is the utility function. So inside this same as like I need to create if root is equal to, find this root is equal to null or not.
The in-order function, why are you passing the vector?
Sorry.
No, man, I got it.
What I have asked, so vector. Why we
I'm
are
wondering
using
why
the
you're
vector?
passing the vector. Yeah, but now I see the add one.
Because we need to find the integer elements in an array. So like they initialized, they mentioned us in that approach. So we need that index value. So that is to be the predecessor at the leaf and in order successor. It is not present in the value. So I need to find in the array. So as the increment types, that is I need to assign. That is why I just assign the vector value. that is correct, right? So use of vector, you know it, right? So why we use vector in Java, you know it, right? So it is mainly used for array list implementation. So that is the use of vector. So where in this program they approached this array list, so that is why I used this vector as the vector integer. Okay, so vector, so for poor performance, that is for to overcome the non-thread environment and all, so we are using this vector implementation for searching, adding and deleting and some of the operations in data structures. So that is the use of vector. So if you didn't know it, you can ask it, no problem. So vector is the main thing. So if there is not a thread safe element, if we are facing the thread safe or else it is not a thread safe, so for those approaches we are using this arrays data structures. In the terms we are using the vectors mostly. Fine, what is the use of vector? You can understand, so clear.
Yes, it's clear.
Yeah, fine. Thank you. So what I have done this, so I know to find the utility function. So here the utility function which checks the data with the vector integer. So the tree checks the empty tree, and here only I'm going to declare a vector value, that is vector integer is equal to vector. So for after declaring this variable, I need to store the value into the leftmost leaf or else to the rightmost leaf. So that is why I am adding the elements and of 0. So that is in order traversal, that is someone of comma a and a comma add of 0. This is for the rightmost leaf, and this the required sum is to be okay. This is not someone, this is sum. So this function store in okay, the function I need to call here, I will check apart from this. I'm going to initialize I, size equal to new int of put key is equal to 1. So here I can call the sum function, sorry, sum method, that is root comma a comma I. So here what is the sum? This is not a sum method actually, in order. Please with recruit sum, create class int.
That int is integer.
Yes, integer. So I need to create a class is told. So I will create a class after this.
Why is in full caps?
Wait, I will check it. So this is one of the what I told. So for vector I have created, right? So I have initialized some I. So I can. So if I'm declared here in the sense, So if I declared int, that is that integer. So likewise normal integer. So if I so I need to create a class for int. So that is class int. So that is I need to call this keyword here. This is not an integer because if I am creating the integer like and successor value, so this is what the n value. So the method
Screen constructor.
guys, can you hear me? Because it's raining here. Can you hear me? Can you hear me, right?
Yes. Yes.
Yes, ma'am.
Yeah, okay. So what I have done, so I can create a normal integer. So whereas normal integer that is can't take, so I need to call the class over there. So that is what I made a mistake. So I need to call the class. That is what I have created for the root. That is what the class I need to call. That is not an integer. So that is the class I need to call over there. So inside the class, so it is my key. It is not data. So that is for key value. So that is the rootmost value. So this is the
Can't
what the
see the
call
program
method I
screen.
need to declare.
Can't see the.
It is not able to view.
No, now it's fine. Now it's got stuck. Okay, it's fine. Fine.
Yeah. Okay. So what I have done is this is not an integer. So where I'm initializing the integer instead of I. So I'm just calling that class name, the static class I just called here. So this static class I overcalled here. So that is what the root value. So I didn't fix an integer here because I have created the vector class. So that is an integer. So this is the vector class I have created. So no need to create a separate integer. So this is the class name where I need to call the static class. So as much confused over there. So this is what they same as the class name. For class name I have created an object. So this adds the value that is sum dot root of. So that is pre-order functionality where it calls. So that in order functionality where it calls, that is root comma a. And what I need to is this confused. Okay, fine. I just created an object for the class, and inside that class I created the data and it is equal to -1. So that is the key value, and I have added the function to print the pre-order traversal. I need to do this after this. So I'm going to create a function or a print. So I can take it as print as a keyword to print. So this is what the function to print the pre-order traversal. So same as like I need to check this condition if it is root is equal to null or not. So after this checking this condition, stored comma key values, that is my print root comma left, and then print root comma root dot right. Okay, so inside this I'm going to, after this only I'm going to write a main function. So I'm going to create an object node r, that is node root is equal to, so new node also you can take, so I can also use get node. So if you use new node it is also fine. So also I can use get node of, sorry, okay, node of 1, same as like, so where I need to call this get node, that is that object name. So where I have so this object name is root dot left is equal to get of 2. So node dot left dot and right. So right node is, I can take it as 4, and so left dot left and left dot right and left dot left. Up to this I can finish it off. This is fine. I can change my input values. So this is my tree. So whereas tree looks like 1, 2, 4. That is starts from 1 and 2 and 4 and 2, 6 and 5. There is no right node. 2, 6 and 5. 5 here. So this I'm going to run a program. So print the function, that is traversals can preset. So I'm going to call the method that is print of root. So I need to also call the method that is sum of, right, the utility function I need to call, that is sum1, that is sum1 of So what will be the output? So that is 10, 8, 7, 2 and 3, 1, 1. So the tree format is 10, 8, 7, 2, 3 and 1. So how it takes? So for 1 I need to find the predecessor, so that is 6 and 4. So this is the 10 to be taken, and for 2, so the nearest value is 6 plus 2, that is 8. So for and then for 2, so the 5 is the only one element there, and there is no element, that is 0 here. There is no element for 6 also, so that is it takes 2 and 1, so that is 2 plus 1 is 3. And for 2, that is takes this element alone, so it doesn't adds this element, that is the nearby element only it takes. Whereas 4 takes, how the 4 to be added? Now how the 4 value becomes 7 here? Can anyone? This is what the output, right? 10, 8, 7, 2, 3, 1. 7 in the place of 4. Can anyone? So this is my output. This is what the input and this is what the output I get. How the value to be checked? Can anyone explain? So I have explained this first thing. So that is 6 and 4 plus 10. And the remaining thing I have explained, that is 6 is the combination. So that is 8 will be the combination, that is 6 plus 2, that is 8. And for this doesn't have any elements, that is it adds this 2 and 1. So how the 7 becomes 4, where it doesn't have any elements here? So that is 0 and 0 is there. How it becomes 4? Anyone just try this, try predecessor and successor. Can we debug? How it comes? How the 4 will become 7? So because this 4 doesn't have any childs over here, how it comes? So that is to be called by this approach, so that the values to be incremented. So for assigning the I value, so that is why I have assigned this integer I here. So I have assigned this vector integer and also initialized this I function here. So the approach is to be followed, where the traversal, the node value takes place from the array value, that is AR of I minus 1 plus AR of I plus 1. So and then increments the I value, that is from I value starts from initializing from 1 to n values, that is to be what will be the nodes here. So up to this it will be initialized, so initialized and the values to be added. So you can check it out. So this is what's on the and I didn't check any assignments for you, and this is the one main program you have to submit it by tomorrow. So how you can check the predecessor and successor, then only I can be fulfilled with you guys. Please do that. If you have any works apart from this, so just this is the only one program I'm giving it to you, just do it by tomorrow, please. We need to find the predecessor and successor value. So with this approach I will attach you the document also. So the program I have done, but you need to explain how it comes. Are you clear? So this is the only one program. So just forget the stack queue assignments and all everything. So you can go through after that. Forget in the sense, no need to go through like that. I didn't tell. So you can go through that later. But this is what the only one program I'm giving it right now. So you need to explain. So I will call you the names by tomorrow. So everyone need to call their names and you need to explain the program. So that is so many functions, because why I gave this program, so many functions and so many static methods is there in a program. So that's why I called you to submit it tomorrow. I will attach you in a chat box. So everyone have to go through this. You have to submit. Understood, Rishita and Kaushik and others? Yeah. Because if you have fulfilled, so if you understand, if you gone through this program, then you can find with the other programs. So that's why I am giving this program to you. So apart from this, others will be too easy. So and then move on to the dynamic program. So dynamic in the sense, can you know what is dynamic program and all? Can you know what is dynamic program? So dynamic program is nothing but the mathematical expressions like so you can study the graph theory and all. You can study it, I think so. The graph theory subject. Have you studied? Hope you studied. So dynamic programming is nothing but I will give you the couple of works to do it. So you have to convert into the simple program. So this the simple the program is too simple. So in this first we are going to see the coin change program. So coin change in the sense I'm going to give you some coins, that is the coin numbers are 5. So you need to find the consecutive values to bring back the value which I have given. So you have studied in your mathematics subject. So far I have given the 4 numbers. So the sum is 1, 2, 3. So this is the coins I'm having. So what the consecutive values, you need to bring back these 4 numbers, that is 1, 1, 1 and 1, 2, 2, 1, 3, 1. Have you remember? So with that sum of this S numbers, you need to bring back this n value. So that is 2, 1, 3, 1 and 3, 2 doesn't come because 3 plus 2 is 5. So you need to find the sum values with the consecutive elements. Okay, you need to find the solution over there. So this is what the coin change problem. So clear what I have said. So this is what on dynamic program. So I'm giving you the n number. So you need to bring back this number. So while adding this consecutive elements by using the possibilities with that element, this is my coins. So with the possibilities, so I need to. So if you are having having the coins 5 1 rupee coins, I need to bring the element. So that is 3. So what are the possibilities to bring back? 1 plus 1 plus 1, and you can take 2 rupee coin plus 1, and you can take 1 coin plus and then 2. So likewise, you need to arrange the elements in a consecutive order. Have you understood the problem? Then only if I'm going to make a program, then only you can find out it. The problem is clear, what I have said. Yeah. So this is what coin change problem. So this is also having some optimal structure to find the coin change problem. So that is what I said. So that is nth coin. We have said nth coin. So that is what the coin I have give. I'm going to give. So that is to be counted using the sum of count. So that is 1 plus 1 or 2 plus 1. So that is what I'm going to give. So these are the functionalities I'm going to import into the program. I can make it as I am going to create a class. So inside that I am going to, so what are the functionalities they have given? So that is SCM. So that is count to be SM, at least one count solution n and n. Okay. So inside that I am going to create a static class. static. So this is what I'm going to in not a integer or void or int. So I'm taking this long count as a keyword or some way, and inside this I'm going to initialize yes, that is what to be displayed in approach, and comma int m comma int n. So before that I need to find the time complexity of the function, that is time and space complexity, so where they have given. So here the time complexity is not given, so also I can found it because no, there is no time, so I can found it the time complexity for the given program. How we can find the time complexity and the space complexity? This time complexity for the given problem is O of mn, so that is what the integer I'm going to give, and O of mn time, the space complexity is O of n. Yes. So inside this I'm going to create a table function that is long is equal to new long of n plus 1. So this is what initializing all the table values as 0, because that is you need to create a table, right? That is 1 1 1 0 1 2 1 3. So likewise I need to initialize the array table size. So that is arrays dot fill. So this is what the inbuilt function to be declared in this Eclipse itself, in the Java itself, not an Eclipse, in the Java. So table is to be 0. So I'm going to initialize the table value as 0. So this is the inbuilt function. So likewise, if you fill the arrays fill table as 0, so that is all table values will be 0. So this array values will be the time complexity, that is O of n. Say space complexity, that is O of n. So that is initialized to be as 0. P of 0 is equal to 1, and I'm going to pick all coins one by one, and I'm going to update in the table. So this is what the initialized table. So here I'm going to pick the all values. So using the for loop, so I'm going to pick the oil coins, that is integer I is equal to 0, I less than m, so that is I plus plus. So it going to pick the all values from the table, and for loop also, that is for declaring n value int j. So likewise matrix you need to define. So like matrix, that is I is equal to 0, I, so that is j is equal to I plus plus, likewise you can define, right? So for declaring as like a matrix, you need to define the coin space j increment. After this I'm going to fill the table, so that is t of j increment t of j minus the stack coin value of I. So same as like that initializing in the table. So I'm going to return the function, that is t of n. This is what the coin change problem method. So method to define the coin change. So like this matrix, you need to empty the table. So after that I'm going to fill up the table using this for loop. So here after itself you can define the main function, public static void main So you can you use scanner. So have you guys used scanner object before? So what is the use of scanner object?
Input output.
Rather than what's the use of scanner?
The input.
Sorry, I can't understand. Get the input package. So rather than you can, so the user can't able to declare the input. So that is the main use of scanner class. So it takes the values into the next line automatically. So if you are assigning some table, or if you are using some matrix condition, like it takes the value into the next table automatically. So that is also the use of scanner class. So I am declaring the scanner class here. So inside that, I'm going to initialize coins. So initialize coins equal to sc dot next int of. So I'm going to initialize array equal to new int of coins. So here I'm going to invoke for loop I is equal to 0, I less than the coins. If I less than the coins, the array size will be automatically incremented. So as like it calls the scanner object. So scanner next int of. So after this for loop, I'm going to declare the money size. Is equal to sc dot next int of. So here I'm going to use my method, that is count of array comma coins comma money. So when I run this program, what will be the output will come? Can I run this program? So what will be the output? So if you guys clearly go through this program, you can definitely understand what happened, what is going on. Can anyone explain why I can't able to run this? Why you can't able to run this? Anyone? Ishita, Harshik. So for running this program, so I didn't get output. Why? It shows empty. Why? As you are learning the code, so you need to understand why it shows like this. This also be the task, because you need to interact in a class, so then only I can finally criticize you. So you need to find why I didn't have any output for this program. So this is the correct program. So what is the condition so what I have used, so why didn't have output? Anyone find it?
Because it's checking for the input.
Yeah, so why I didn't initialize, I didn't give any input into my program also. I just initialized the conditions and all. I just initialized the method and I just used the scanner object to get the input. I didn't use anything. And find the main logic over there with the program. So what the program consists of, you can find the main logic over there. If you can find it now itself, you can do it. So dynamic programming, as I said, in the stage itself, it's a dynamic programming. So what is the use of dynamic programming? So why I said dynamic? So dynamic program in the sense you can't able to find. So this is just algorithmic functions. So this is the main thing you need to find out. So this is what the algorithmic technique to find optimize the problem. So I gave you the problem once. So to use of code. So if you are using in a normal way, so if I'm giving you the coin in your hand, so if you find the consecutive pairs in the sense, you can easily find out. So I can arrange like this way and I can use the sum of this 2 plus 1 3 and 1 plus 1 plus 1 3 and again 1 plus 2 3. So likewise you can arrange it. But if you are as a coder, so you need to find the dynamic programs. So you need to find or fix the problems in a dynamic way. So you need you need to understand the algorithmic techniques. What are the algorithmic techniques we are using in the programming stages? So that is why I have said, so it is a dynamic program. So dynamic program in the sense we can't gather the output there. So it is the algorithmic technique to break down the problem. So that is what we have written here. So this is what the algorithmic technique to break down the problem. So we are using, so to solve the sub problems, like if you are using any applications over there, so applications, real time applications, you can use it out. So this is what one of the algorithmic technique, but to solve the dynamic program. So that is what said to be dynamic program. Okay, whereas same as like you can see the time complexity and the space complexity finding outs. So this is also will be the dynamic program. So you can't find out the result over there. So you can't find out. So where the results will be. So you can clear it. So the time complexity is 1 and the space is 1. But where it is to be. So that is what it's said to be dynamic. Okay, the time is today. It's too much time taken to solve this program and all. So likewise, you need to find any one of the dynamic program using trees, any one of the data structures. So I have give you the 2 tasks. Definitely, I think tomorrow will be the last class. I think so. Definitely, I will ask you the questions so that what I have attached to the program, so that you need to explain, that is predecessor and successor. You need to explain this program. And one more thing is like you need to define what is dynamic programming and also go through the sections which I have taught 3 days, because tomorrow if this is the last day in the sense you can clear cut out understand this. And so guys, please let me know any discomforts or any I need to change over there. So anything, you just feel free to say here, because I didn't take that as a negative point, so I can take it as my positive point. I can change over in my career. So that's why I'm asking you.
It's fine, ma'am.
It's great then, because you guys are listening the class day fully. So I understand your situation, but you need to find out what is going on. So that's why giving you the task and all. I think hope you understand about this and go through the sessions. That's why I'm attaching you the programs and PPT every day. So go through when you're having the free time. You can ask me whether you are facing any issues and if you are facing any technical doubts and all. To this. Admin's link where I have found the feedback form. What about the feedbacks that you're giving?
Good, ma'am.
Good.
Yes, ma'am. It's
Actually,
nice, ma'am.
I can't